Here's a video going over certain problems from the homework. Right now, let's go to question 2 from 4.2. It says complete parts A through H for the data below. We have the X and Y. It says by hand draw a scatter plot treating the X as the explanatory variable and Y as the response variable. So X is on the horizontal axis, Y is on the vertical. And then it looks like every unit is on the X scale is 1 and every unit on the Y scale is 2. So we got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 2 by 2 would actually be, this would be a 2 by 2, 3 by 4, 4 by 8. So I like A. I think the key is realizing that the Y scale is doubled. Find the equation of the line containing the points 2, 2, and 7, 2. Alright, so this is kind of a unique problem because this is more a problem from an algebra course, but we can do it here. We didn't really, I don't think there was much guidance on how to actually write an equation from 2 points. So let's say we have 2 points and our line goes through these 2 points. So we need to write the equation of the line, alright, in slope-intercept form. So the first thing we have to do is find m, the slope. And that's y2 minus y1 over x2 minus x1. And we can just let our first point be x1 and y1, and our second point be x2, y2. And now from there, we can say, well, m is going to be 12 minus 2 over 7 minus 2. That's 10 over 5, and that equals 2. So m is 2. And now we can use, we can go about doing this a different way. We can use the y minus y1 equals m times x minus x1 formula. So that's y minus 2 equals 2 times x minus 2, and solve for the y. Y minus 2 equals 2x minus 4, and now add 2 to both sides. It's a whole lot of 2's. Y equals 2x minus 2. So let's plug that in and check. Graph the line that you found. Well, in order to graph the line, you have to first plot the y-intercept. So the y-intercept is at -2. The others all have a positive y-intercept, and this has no y-intercept, it goes through 0. But this one looks like it would eventually have a negative intercept. And so for that reason, I'm going to choose this. And now, by hand, determine the least squares regression line. And the truth is we don't do the least square regression line out by hand. It's too painstaking for us to do so. We utilize technology, and that's what we're going to do here. So I'm going to open StatCrunch, and I'm simply going to create the regression line, hit compute, and there it is. There's my regression line. That's what I'm going to use. Alright, so they actually wanted me to round it off to 3 places. So we can do that. It's going to be -1.395 x plus 1.953. Let me double check that. let's see, we have 1.953 and also negative 1.95. Okay, we got it switched around. (1.593) times the x and then negative 1.395. Let's double check that. Wait a minute. What? 1.953. 1.953. Oh god. There we go. 1.953x and then minus 1.395. Graph the least squares regression line. Well, the least squares regression line is going to have a negative y-intercept. And there's only one up here that will have a negative y-intercept. Like this line will eventually cross the y-axis at a negative 1. And so for that reason, I'm going to choose that one. Alright. Compute the sum of the squares of the residual. Alright, so let's try to compute the sum of squares residuals one more time. And we're going to go into, let's see, stat, regression, simple linear, choose the x to be the x, the y to be the y. And when we go down, we want to save a column for the residuals. And now we have the residuals have been saved. And now what we're going to do is create a new column. We're going to compute expression. We're going to build the expression. We're going to use the residual column. And then we're going to square it. So let's hit OK and then compute. And what that did was squared it, and now the only other thing to do is to calculate the sum of that column. So we're going to go back into compute from column, select the column, and at this point we're simply going to just add it up. Let's go back. Instead of here, let's go to compute expression residuals. Hold on. So it keeps giving us the, okay, no, let's make sure we do this right here. So we have residuals. We simply just want to take the sum of that column. I mean, at this point we can calculate the sum pretty easily just by grouping R2. Hit compute. And the sum of the residuals is 3.1627, but that's what I put in earlier. 3.163. Oh, did I not round? 3.162. Let's just do that. They're saying that it's 4, and it's probably 4 if you do it out by hand. But oh, okay. Yeah, three. Okay, use the compute the sum of the square residuals of the least square regression line. Yeah, that's something totally different. Then that's going to be 3.163. Okay, yeah. We didn't compute it from the original line. We could have. It's going to give us more error because that is not the least squares regression line. It's just an estimation. Um, and so that kind of reminds us, like, how do you actually compute residuals in the first place? So let's look at this for a second. So what we'll do is see. If we have some line, some graph per se, and let's say we have some line here, and we also have a bunch of dots, so on and so forth. Some dots will be on the line, some will not. So consider this was a scatter plot, positive, strong association. We have a line of best fit. What we need to do is be able to calculate the residuals, every single last one of them. And the way you do that is you take the observed point and the predicted point and you subtract them. So in this case, it will be positive. So you're only looking at the y values, and we want to look at the difference between them. And when we take this value, the observed value, and then the predicted value, the value will be negative. So it's below the line of best fit. But at the end of the day, you're simply going to square it. You're going to square it. Now let's say our line is y equals, let's see, our line of best fit. Let's just say it's x plus 2. It's really nice. Easy to calculate. And we have a point. Let's say that our point is, let's say this point. Let's just say it's, well, let's put a point here. So let's say that point is 1, 2, 3, 4, 5, 5, and then 1, 2, 3, 4, 5, 6, 7. So 5, comma 7. So the real point is 5, 7. But what happens if we were to predict the point? Actually, it's not supposed to be the same. So let's make this 5, 9. And let's make our predicted value, when we plug 5 in, y is 7. So 5, comma 7. So 5, 7 is predicted, and 5, 9 is the real point. Let's just make believe. So we have the two. What you have to do is subtract them. Once you subtract them, you have a residual. The 9 minus the 7 is 2, and then you have to square the 2. Alright, so that's what's happening. You're doing that for every single last one. Alright, there's a systematic way, the chart that was in our study guide is how you can go about doing that. Let's take a look at our notes in the discussion section real quick. Let's see here. Here's an example of calculating a residual. So you have to do it for every point. Again, to get the predicted value, you plug 3 into the equation, and you get your predicted value, but we also have the real data value. We want to know that difference. And here's how you would calculate the sum of the squared residuals. So you have your x and your y, and then you compute the approximated y values. You can do that in the table here. And then you subtract them. And then you square them. And at the very end, you take the sum squared of them. Excel may be able to do this. There's a few ways to go about doing this in Excel. I did demonstrate how to do this using StatCrunch. So it worked out. Notice that in StatCrunch, when you do it, the sum square residuals turned out to be right here. Alright, that's the one you need to be aware of. The other one, the other line didn't really matter. Let's look at some more homework problems. So for example, let's look at problem number 8 from 4.2. So determine the least squares regression line if we click on the data. Alright, so there's our data. You can just open it in StatCrunch. Graph. Actually, we go to Stat, regression line, simple linear, X and Y, compute, and there we have it. So I'm getting 1.2 plus 2.3x. So 2.3x, 1.2 is D. Graph the least squares regression line. Well, it's going to be pretty easy to graph, right? It's going to cross at 1.2. It's going to cross the y-axis at 1.2. And it's going to be fairly steep. So let's see which one does that. 1, 2, 3, 4, 5, 6. I like this one. Well, which one did I just look at? Oh, forget. No, that's not it. Oh yeah, 1.2, fairly steep. Yep. Let's choose that. We're just doing this quickly just to give you an idea of how to do this. I'm not doing your homework for you. I'm really simply just trying to give you an idea. So it says the equation of the line containing the points -2, -4, and 2, 5 is this. Compute the sum squares residuals of the given data set for this line. Okay, so they want you to compute the sum squared residuals for this line. It probably would be a good idea to do this in Excel because then you can calculate all the y's really quickly. So let's see how we could do this in Excel. So we're going to calculate y prime here using that formula. So what we're going to do is do equals this column. I'm going to call it estimate. What we're going to do is say equals the sum of, hold on, we'll do equals the x times 2.25 and then plus 0.5. We got -4, and if we do it all the way down, those are the values. And now in the next column, we're going to square each one. So the formula will be this squared. And now what we'll do is take the sum of this column equals sum and I got 51.875. Oh wait, hold on. I think we forgot to. Oh yeah. We forgot to subtract it from the y. Yeah, we need to delete these. Okay, so we need to subtract the estimated from the. Yeah, that was a big mistake. From the observed. So we're gonna do equals this minus this. Now it's time to square. And then we can also, yeah, well, let's square it first. And now let's take the sum. So we type in equals sum 4.375 is what we got to. Now what's the sum squared residuals of the least square regression line? Well, that's the one that StatCrunch can help us out with. We got 1.9. And yeah, that was that. There was another question about 4.3, so let's get into 4.3 real quick. Let's look at problem 4 and 5. So they want you to draw a scatter plot based on the data and then answer a bunch of questions. So you could do this in StatCrunch pretty easily. So now it's just a matter of choosing the one that looks like it. Starts off kind of slow and then it shoots up. Looks like A. Determine the correlation between the two variables. That's a really good question. They want to know the R. So 0.989, or you can round it off to 0.90. They want 3 places. So 3 places looks like it's 0.96. That's not this one. 0.979. 0.979. Okay, wait, hold on. The correlation between distance and spiral is what? Just double check that. Oh, it's just the r, not r squared. So 0.98, so 0.900. This is the r right here. We have to round it to 3 places, so 0.990 is what we need to round it off to. Does this imply a linear relationship? Yes, it does. Compute the least squares regression line. That was provided by StatCrunch. There's your y-intercept, and this one's going to be your slope. You would round it off, of course, 3 places. So that was that one. Let's take a look at number 5. It appears to be a very similar question. The table is so long they have it in columns, so it's a lot of data here. You just open it in StatCrunch. Choose your X and Y. Compute, move it over. This is what it's looking like. We do have an outlier. And you would choose the best graph. I like B. You can see by the outlier. Determine any potential influential points. Probably the one that's at 36 in that. Find the least squares regression line by using all the data values. Okay, and then it probably is going to ask you to find it after omitting the outlier as well. But there's our least squares regression line right there, and that's what you would use to answer the question. So this is good practice. Hopefully this was helpful.